If we were in a traditional statistics class, we would expect you to be able to do this, which is plug in the formulas using a calculator and find the t-value. But we're not, so actually we are. We are going to make you do that, but we're not going to make you find those bits there. So what we've got is we've got Excel here, which gives us the mean, the standard error, the standard deviation, and the count. So you can see where these different numbers are coming from. So we've got X bar, which is the mean of the sample. Okay, so sample mean. So that's why that's that 26.78. And then you've got this mu, which is the hypothesized mean. So that's 28.9. And then there's these two things here. But in fact, you don't even need to worry about that because those two things there go to make that. So what the computer actually does is it takes the standard deviation and the count, which is that bit and it turns it into a standard error. So in fact, you can just go straight to the standard error. Now don't worry, we'll be doing this again in a minute. Okay, so we found the t-value of 8.57. What that means is that the mean is about 8 standard errors from the hypothesized value. That's a really, really big t-value, by the way. Anything bigger than 2 is a big t-value. So you know that you're going to reject the null hypothesis. But we generally are not going to work with t-values. We're going to look at p-values. So if we were going to look up a p-value, we would use the t-distribution, and we would put in x, which is the 8.57. We would put in, so that's calculated value. So we've calculated 8.57. We've got our degrees of freedom, which is the sample size minus 1, which don't even go there as to why that is the case. You just do it. And then the last bit here is that it wants to know how many tails, and we say it's 2 tails because we already worked that out as the alternative hypothesis is not equal to or different. Okay. So we get an answer of that 1.2 e minus 13. Now, do you remember we did those e things at the beginning of the year? That was the reason we did this, is so that when we get that now, you know what it means. It means 0. Lots of zeros, 1, 2, 2, which is basically 0 because it's really, really little. So it's much less than alpha. So remember, alpha was 0.05. This is pretty much 0. P, is this low or high? Hands up if you think it's low. Hands up if you think it's high. Good, it is low. So P is low, null must go. Therefore, we have strong evidence to reject the null hypothesis. We say it's strong because this number is very, very small. If it had been 0.04, that's very close to the cutoff, so we wouldn't have strong evidence, we would just have evidence. So, as a conclusion, and you should always write it in words, the average desirable age for marriage for male students is different from 28.9. And in fact, we can see that it's less, and we could say that that would exist in the population. So generally, if you asked any male students in the population what age they thought they would want to get married, on average, it will be less than the actual average marriage age. So if we look at this next page, it's pretty much the same as about page 3, I think, but we just need to complete this. So we calculated the p-value to be 0, or we can call it 0.00. And so our decision is we reject the null hypothesis. Now, you're expected to be able to write this. Most of the questions in the NPQ, you'll just have to pick which is the right answer, because we have to have it able to be marked by a computer. But in the proctored quiz, you're expected to be able to write this stuff for the chi-squared analysis, which we'll be doing next week. But the principle is the same. Sorry. excuse me, I'm just going to have a... I want you to try and do that. Do the first two.